Okay, so in the previous video, we learned an example about Disney World. So far in this chapter, we learned about expectation, the average, the mean, the expectation. They are the same thing. And the idea is simple. It is the sum of probability-weighted outcomes, and we are using the average to make a decision. So when you have a lot of numbers, you cannot compare them. Like you don't know, like when you have two groups with a lot of numbers, you don't know who is greater. So then summarizing those numbers to one number is one possible way is the mean. It is definitely the most common and most like maybe one of the most easiest way to summarize data and like most convenient, widely used. Definitely that is the first choice. However, it is never perfect. So from now in this chapter, the remainder of this chapter, and maybe the next chapter, we are going to learn the potential problems with just using only the mean, right? So here, let's think about another example. We have population by state, right? So from 2010 census data, and the count is maybe millions. So and the vertical axis is the number of states. Say below 1 million, there are 8 states. 8 states have less than 1 million, and California is the most populated state, which is in the interval between 37 and 38 millions. And the second largest is Texas, which is between 25 and 26 million. And New York, Florida, and two states, two states are here, another state here. It is histogram for each interval. For each interval, it shows how many states are within that interval. Okay, so the data, I can show you the real data. So we have data from California, the largest one, down to like Wyoming. By the way, DC is included as another state. Actually, it's not the. It is DC is larger than Wyoming and could be larger than other smaller states. Anyhow, so there are 51 states, and they are ordered from largest to the smallest in their population 2010. Okay, and what I want to tell you here is, okay, this is a data, so you can calculate the average. So let me show you the average, how to calculate the average. So like say in this cell, I'm going to calculate average. So then simply average, and in parentheses we open parentheses and drag the area where you would like to calculate the average from, and close the parentheses. So this is the formula, simple formula to calculate the average, right? The answer is nearly like 6 million, 6.05 million, right? So average population in 51 states is 6, which is here. Mean, the average is 6.05, so nearly like on the lower side of this interval. Okay? Then, what I wanted to show you here is, say 6, if you think about 6, then it comes in between these two states. So average would be in between these two, Tennessee and Missouri. Okay? Right? And then what I'm showing you here is above the average, there are, let me show you here, 17 states, you can see the count. 17 states are larger than the average. On the other side, let's see, 34 states are below the average. So it is a little bit like it's like not a little bit, quite unbalanced. So we are learning the mean as a central location, the representation of the data. However, like it is kind of, it's not balanced. So there are fewer states, half of the states are above, but twice more states are below. So in that sense, it can be misleading. It's not exactly the center, not the in the middle. Okay, so we define an alternative measure of central location, which is called median. So as I said, in this example, the mean is not balanced, right? Not balanced at all. And so we are going to define another measure to balance on two sides. That is, simply cut the sample in half and choose the middle one. That is the median, right? If you like, in other words, given the median, half of the sample, half of the observations are smaller than the median, and the other half of the sample is larger than the median. So we are going to denote this as median of x, or simply MED of x. And back to our example. Average is here. Average was calculated like this and here, but let me delete this. But what is the median? Because there are 51 states, if you choose 27th, say, let's think about Kentucky. So if you choose Kentucky, like, and then above that, above Kentucky, there are 25 states. And below Kentucky, there are the other 25 states are below Kentucky. So in that sense, Kentucky is the balanced middle center, right? It is the center in this sense. Okay, you get the idea. And let me briefly show you how to calculate the median. So average was calculated as equals average and the area in the parentheses. Median is similar. Median, use median function and choose the numbers. Choose the data, select data, and close the parentheses, right? Within the parentheses, then enter it. Then you get 4.33 million, which is exactly Kentucky's population, right? The median is choosing the middle one, middle rank, perfect middle rank observation is the median. Okay, you get it? Okay. So then you realize that the mean and the median are different, usually different. They are, in most cases, they are could be quite very different, and in some cases they may be similar, but in general, mathematically, they are different. So let me briefly show you the idea how to calculate the median. It is pretty simple. When you have, say, I will just take 5 states, and in this case, how to calculate the median of these 5 states. Because there are odd number of observations, you can just choose the middle one. The third one is the middle, but you have to choose the third smallest or the third largest one, right? So what you can do is rearrange the observations in the ascending order, or first smallest, second smallest, third smallest. So Oregon is the middle, or from the largest, first largest, second largest, third largest. Again, the same Oregon. So the median is Oregon. Oregon's population is the median. Okay. But just as a comparison, in this case, if you calculate the average of these 5 states population, you get nearly 10 million. But the median is less than 4 million. So the difference is more than twice, right? The mean and the median are quite different. So in this case, pretty easy, nothing to worry about. But when you have even number of observations, it's still a little tricky, but not a big problem. So when there are, like now, I'm going to consider New England states. There are 6 states, and I already ordered the states from the smallest to the largest. There is no middle. right? So the middle ones are these two, New Hampshire and Maine. And then what we are going to do is we are going to take these two states and take their average, right? Take the middle of the middles. So the median is calculated as 1.325. Okay? In this subsample, the mean, if you calculate the mean of 6 states, it is again different from the median. Mean is 2.41, while the median is 1.325. So when you have raw data, calculating the median is not a problem at all. It is intuitive, and you know what we are doing. It's actually easier to understand, more intuitive than the mean, right? However, what the problem is, when you have probability distribution table, it is not as intuitive, right? Mathematically, so we want median to satisfy like this. So we would like to have that, we want to have that probability that a random variable is smaller than or equal to median. We hope it to be 50%. And the other side, x greater than or equal to the median, should be 50%. But it is not easy to satisfy both equalities at the same time, because the probabilities are bunched. So there are probability mass at like 1, 2, 3, so on each interval. So it is not possible to exactly make it exact 50%, right? If possible, that is the median, but this may not be possible. So then we are going to consider this condition, mathematical conditions. You may think it's weird. How can we make both sides greater than 50%? That is possible because equality is overlap in two probabilities. The equality part, x smaller than or equal to, x greater than or equal to, the equal to parts are overlap. So because of them, we can make both probabilities greater than 50%. This is what we are looking for. So now it becomes a little more trickier. Okay, we can think about another example to see what's going on. Suppose that you have a probability distribution like this, right? Like say we are interested in the number of pets in a household, randomly chosen household. We ask for the number of pets, and 28% of households have 0, 21% have 1, and 19% have 2, 17, 3, 15%, 4, say, or more. Here, we need to find the median. How can we do that? Like, the first thing I recommend you to do here is to calculate the cumulative distribution function. So this is pretty useful to calculate the median, but also if you study statistics further beyond this course, you may realize how important this object is. Cumulative distribution function is mathematically the most important characterization of a random variable. So I'm telling you just right now, you don't need to know about that, but I'm telling you the CDF, cumulative distribution function, is very important. We will study that importance of this guy in chapter 6, maybe. Anyhow, let me show you how to utilize this. So we have probabilities for each category, right? For each interval or category, but we are going to cumulate them. So we will calculate probability not just within a category, but probability, say, up to a certain point. So for example, CDF, like I will make another row in the bottom. So first CDF is the probability of the probability that a household has 0 or fewer pets, which is simply just 28% because there's nothing below. So 28 pets. But what the difference comes up here? I'm calculating cumulative probability up to 1. So that means I'm calculating probability of households having 1 or fewer pet. That includes households having 1 pet and 0. So include those two, makes 49%. And then again here at 2, I'm going to accumulate 1, 2, 3 probabilities. So 1, 2, 3 probabilities, 28 plus 21 plus 19 probability, 19% is the probability of households having 2 or fewer pets, right? These 3 categories. Likewise, you just literally accumulate the probability, add up the probability as like this. So in the end, at the largest category, the cumulative probability is 100%. So it includes all the categories. So this is the last row is the cumulative distribution function. And for example, if you choose 3, and if the input to this function is 3, then it returns probability summing these 4 numbers, which is 85%. Okay. And then, I did not use the technology, right? You know how it works. But what I'm telling you, going back to the definition of the median, so you can see why this cannot hold. There is no 50%. 50% does not exist. Maybe the closest is 49%, but we do not use this as the median. So I will show you. So we need to make both sides greater than 50%. And then we have to choose 2. So this is smaller than 50%, so the first inequality fails. So these 3 numbers satisfy the first inequality. Then among them, only this number 2 satisfies the other inequality too. So think about this. Probability smaller than or equal to 2 equals 68%, which satisfies this inequality. But on the other side, probability greater than or equal to 2 is sum of these 3 numbers, 19 plus 17 plus 15. If you calculate that, that is 51%, which is greater than 50% again. Therefore, the median is 2. Right? As I said, both probabilities are greater than 50% because this 19% is included in both sides, less than or equal to 2 or greater than or equal to 2. So because 19% is counted twice, you can satisfy 2 inequalities at the same time. So it's a little bit counterintuitive, but this is how we define mathematically the median. And again, another thing you have to be careful is we do not choose this number, even if this is the closest to 50%, but that's not what we choose as the median. The median must satisfy these 2. Okay? So then I changed the numbers a little. So household size, number of family members, not the pets. I will stop the video here and leave it to you. So you try this question and continue to the next video after finishing this question. Okay, find the median household size, and how to do it is clear. Calculate the CDF, cumulative probability, and check these 2 conditions. Okay. See you in the next video. Bye.